Welcome to Insight Engine Academy. In this video, we will discuss a topic matter around us. Let us see what is a matter. What is matter? Matter is anything in the universe which has mass and occupies a space is called matter, right? Now, anything in the matter, like examples, this pen is a matter, right? Because it has some mass, like let's say 10 gram, 15 gram, okay, 20 gram, like that, which also occupies some space. So anything in the universe which has mass and occupies some space is called a matter. Example, the pen, a book, a chair, water, air, etc. Okay, are the examples of matter, right? Now everything in the universe, if I take a universe, everything in the universe is broadly divided into two categories. One is a matter, let's say one is matter, the planets, the trees, the air, the water, all, see, we say they are matter. And other form is other thing, rest of the universe, it has energy. Other one is energy. One is matter, one is energy. Let's say matter. I've written already examples of matter. This pen will take an example of matter because it has mass and it occupies some space. Now how about energy? If I take a example light, if I take example light, right? Can we measure its mass? Can we say 10 gram light, 20 gram light? No, we can't say. We can't express mass of light. Can light occupy space? No, light doesn't occupy space. Since it doesn't have mass, it doesn't occupy space, it is not a form of matter. Then if it is not a form of matter, then what it is? It is a form of energy. Other examples of energy are light, it may be sound, right? Heat, right? Etc. Like electrical energy, etc. are the examples of energy. So everything in the universe is divided basically into two categories. One is matter, second one is energy. Matter is anything that we see around us, right? That we have, that we use, like pen, book, chair, air, water, juices, milk, petrol, oxygen gas, hydrogen gas, these all are, we say, matter, right? In this lesson, we are going to discuss matter and different forms of matter, right? And properties of different states of matter. Okay, now anything that in the universe which has mass and which occupies space, let's say one is mass is one measurable quantity of matter, second one is occupying space, this occupying space is also another measurable property of matter. Let's see mass. How do we express mass? We express mass in gram. We express mass in kg. We express mass in tons, right? Or we express mass in quintals, etc. These are the various units of mass where we express its mass. Like, this pen is like, let's say 10 gram, the fruits are 2 kg, okay, or the rice, say, right, in quintals, like the metals like iron and all those in tons. In different instances, different convenient units are used to express mass of matter. And then coming to next, occupying space. If I take any solid, let's say any solid, generally let me take a solid which is represented like this, a three-dimensional object, right? This object, it occupies some space. It occupies some space, and the extent of space occupied by this space, this region, is called its volume. It's called its volume. Then for expressing volume, we considerable all the three dimensions. We consider the length, we consider the height, we also consider the breadth. Okay, so volume comes equal to length into breadth into height of a regular objects, and the unit is centimeter into centimeter into centimeter. This is centimeter cube, right? Or centimeter cube, also written as cc. This is CGS unit of volume. Then in SI system, we write three dimensions: meter, meter into meter, which is equal to meter cube. This is a SI unit of volume, the SI unit of volume, and whereas cc or centimeter cube is CGS unit of volume, right? Other than these units, centimeter cube and meter cube, we also express volume in other units, like other units. In case of liquids and gases, okay, the units used to express their volume are generally milliliter or liter. Milliliter or liter. These are the units used to express volume of liquids and gases, right? Whereas in case of solids, we generally express their volumes in cubic centimeter cc or meter cube. This is a volume. So every object in the universe, okay, which has some mass, where its mass expressed in gram, kg, tons, quintals, etc., which if occupies any space like in milliliter or liter or cubic centimeter or cubic meter, then if it has volume and mass, then we say that part of the universe, that particular substance, we consider it is a matter. It called a matter, right? I hope you understand. There are many examples of matter, like I told you, pen, book, chai, water, air. Try to identify different matter around you, okay, which is present around you. Try to identify so you can understand this topic better, right? Now, let us see the properties of matter. So now the properties of matter, right? First one, matter has mass, right? As we discussed now, matter occupies some space, we consider this is volume of the matter, right? Then what other properties that a matter generally have? So the first one is matter, every matter is made up of tiny particles. Matter is made up of tiny particles. Matter is not the continuous one. Matter is not the continuous one. Okay, if you look at anything, if you look at your pen, right, it seems a continuous one. Okay, or a chalk piece, it appears like continuous one. Even the wall that you see, it appears, it seems like continuous one. But any matter, that no matter is a continuous one. Every matter is made up of tiny particles. Every matter is made up of tiny particles, right? And these particles, how can we understand this? Okay, matter is made up of tiny particles. We have a few activities to understand that matter is made up of tiny particles. So let us see here. Let me take a beaker. Let's see an activity. Using this activity, we understand matter is made up of tiny particles, right? First one, let us take a beaker. Let's take a beaker. Now let's add few ml of water to the beaker. Let's say 50 ml of water, some amount of water. Then let's add a let's add some amount of potassium permanganate. Let me add here, this is let's imagine this blue color one. This is potassium permanganate. Potassium permanganate. Let me write its name. What is it? It's potassium permanganate. Potassium permanganate, right? And this potassium permanganate is actually a purple color substance. It's a purple color substance, right? When this potassium permanganate is added to water, what happens? This purple color substance is generally soluble in water. It is soluble in water. Then what happens when you add potassium permanganate, right? Potassium permanganate is chemically, it is in shortly represented as capital K, Mn, capital M, small n, O4. This is called chemical formula of potassium permanganate. This potassium permanganate, purple color salt, which is soluble in water, when added to water, this is, what is this? I've taken, this is a water. Then it dissolves in water, and you'll see this solution, this water now turning into purple color, So this is what is it? This is all the water, let's say, that we have taken. This is the water, right? In this salt, soon after adding into the beaker, then it start dissolving. You see here, this is the substance that we have added, potassium permanganate, and it start dissolving in the water. And next, soon after adding it in within few seconds, what happened? This color completely spreads throughout the level of the water. This is the level of the water. Let's say this is total water that we added, that we have taken, and this soluble potassium permanganate, which is purple in color, right? Why I have selected this salt? We can take normal common salt. Common salt, when added to water, it forms a colorless solution. But when this purple color potassium permanganate added, the solution completely turns to purple color. Then after some time, what happens? Within seconds, like this total purple color salt, it dissolves and changes the color of the entire solution, right? And you know, we have added a small amount of substance to water, but finally it is able to convert the color of a total solution, right, into purple color. And from this we understand it is possible only if the substance that is added made up of smaller particles, and that smaller particles get separated from the substance and spread throughout the volume of water and turns the complete color of the solution to purple. So this is now the purple color solution of potassium permanganate, right? From this activity, we understand matter is made up of particles. Matter is not a continuous one. Matter is made up of particles. You see, this smaller substance is able to change the color of entire substance because it split into particles, and that particle occupy throughout the volume of the water. Okay, now let us understand these particles. You know, matter is made up of particles, but how tiny the particles, how small the particles are. I'm written here, matter is made up of tiny particles, right? But how tiny the particles, to understand, let us discuss one more activity. Okay, one more activity we can be discussed here to understand how tiny the particles are. How tiny the particles are. How tiny the particles, we'll see. One more activity here. In this activity, what shall I do? I take a test tube. What is this? This you find in chemistry labs generally, and this is called a test tube. Test tube, right? Let's take a test tube. Let's fill 3/4 of the test tube with water, right? With water. Add a pinch of potassium permanganate. A pinch of potassium permanganate okay, to this test tube. Then soon after you add the potassium permanganate to test tube, what happens? As in the above case, what happened? This color of the total water changes into purple color. Okay, since I'm using blue, it's actually purple, right? This is a purple color solution, okay, of potassium permanganate in water. So this total solution is turned to purple. So let me put some closer dots of purple, so that it is a purple color solution. And then what shall we do next? Let me take another test tube. Let's say this is test tube A, our first test tube, and let me take another test tube of similar test tube, another one. Let's say this is test tube B, and let me take the same amount of water, let's say 3/4 of water, right? And now let's do it, okay? Then, or just a little lesser amount of water than in the previous case we shall take here in this case, so that let's say this is the amount of water, level of the water that we take here. This is the level of the water we take. And now what shall we do? From this solution, let's transfer like few ml. Let's transfer few ml of this solution into this test tube. Then what happens? This is purple color solution. This water is colorless solution. When you add purple solution to colorless water, what happened? This solution added to it makes the water, right, in the test tube B into purple color. So we get a solution of potassium permanganate again in this test tube, right, like this, right? Then what do I do in the next case? So that there is a since I added few ml of this solution into water, there is a rise in the level, right? So this is added potassium permanganate solution, right? Since I added only few ml of this solution into water, and what difference you find between these two test tube solutions? In this solution, whatever in a test tube A, the solution is dark purple color, but when you add a few ml of this solution into test tube B, whatever the solution formed here, it is a bit lighter, like not it's the darkness, the intensity of the brightness decreases. Then what do? I take another similar test tube C. Let's say similar test tube. This is test tube C. Now to this also let me add few ml of distilled water or just normal water, right? And now I just shift some amount of, okay, from this again few ml of this solution added to this solution. Then what happens here? This color also changes. Color of this solution also changes, but intensity decreases. How dark it is, then the brightness, like the concentration of the solution decreases, the color little fades away. When you compare test tube A, test tube B, test tube C solutions, what happened? The brightness of the solution, color of the solution gradually decreases because we've been transferring, and this is repeated many times. It can be repeated many times, so that if I take a similar test tube, right, and I take few ml of water, right, and I transfer some amount of this solution into this test tube, then what happens? This level also increases, but you can see brightness decreases, right? And now you can see gradually what is happening. The brightness of the color solution decreases. Color of the solution decreases. Like that, we can repeat n number of times. We can repeat it number of times. So for every time it changes the color of the solution purple, but the brightness decreases. Brightness of the solution decreases, right? It is only possible because you see initially we took very small amount of potassium permanganate, KMnO4, very small amount of potassium permanganate to the test tube A, and that small little amount of potassium permanganate is able to turn the color of water into purple in many times. As you repeat it in a number of times, in every time the water color changes into purple color, and the solution, the darkness increases, because, right? So This is possible only when the taken amount, the smaller amount of potassium permanganate is not continuous one, it is made up of particles, but that even small amount of substance can produce large number of particles, and that large number of particles distribute throughout the volume of water and changes the color into purple color. And from this activity we conclude that any matter, not just potassium permanganate, like this every matter is made up of tiny particles, and that very tiny particles, so that even small amount of substance you take that contain large number of particles. Now you can have a doubt, sir, you said every substance is made up of smaller particles. If I throw a small stone into the test tube, that stone, can it turns in the color of solution? Can the stone dissolve? That is insoluble. Stone is insoluble. When it is insoluble, why it is insoluble? Maybe all the particles are attracted very strongly so that they can't split when dropped in a water. So activity can be repeated by using various salts, various soluble substances. We can try with, even you can try with common salt also, common salt, right? Instead of potassium permanganate, you can take common salt, you add some amount of common salt to it. So what change you see? Do we see any color change? Now we don't see any change in color, but there is a change in the taste. Water turns to salty. Now if you transfer few ml of salt solution into another test tube containing water, it also, this now in test tube B, all the water also turns into salty, but the saltness is not equal to the test tube A. The saltness decreases a bit. Now if we convert this into another test tube containing water, and that water also turns to salty, this also turns another water salty, but in each case what happened? The taste, the saltiness of the solution gradually decreases, which means the saltness is because of salt particles which are very tiny and distribute, they can occupy all the spaces and turn all the solutions into salty, right? So using this, so we can repeat it n number of times by also taking common salt. Common salt, I'm telling you again, cannot change the color, but it changes the taste of the solution. So from these two activities we understand, from first activity we understand matter is not continuous one, but it is made up of tiny particles. But in second activity we understand how smaller each particles are. The particles are very tiny, so that you see how tiny. If you see like a single drop of water, what is this, Nana? This is a drop of water I am taking, single drop of water. You see, right? Like single drop of water that nearly contain 10 to the power 21 water particles in it, water molecules in it. Each molecule is considered as a particle here. You imagine single drop contain nearly 10 to the power 21 water molecules. Now you can imagine a single drop seems very small, but it really contain very large number of molecules, and that is possible only when each particle is very tiny. Okay, and these particles are very tiny, so that we can't even see them under microscope. Generally we say microorganisms, which are very small but can be seen under microscope, but these particles with which matter is made up of is still smaller, and even it is not possible to see them even under the microscope. Even with a powerful microscope it is not possible, right? We can't see the particles. So from this we conclude the another property of matter, that is matter is made up of tiny particles. We right? Matter has mass, matter occupies space, matter is made up of tiny particles. Okay. Now we also understand other properties of a matter. Now let us look at properties of particles of matter. So till now we discussed every matter is made up of very tiny particles. Now that tiny particles have some properties. What are those properties? Properties of particles of matter. So after we discuss these properties of particles, we also discuss some other properties of matter. Okay, now the first property, let's see, particles. As we know, particles are very tiny, and these particles have attraction forces between them. What is it? Particles have attraction forces between them, right? Is it really exist? Yes, particles have attraction forces between them. Let us see, for example, the common thing that we know is water. We'll take water, right? Water chemical formula everyone knows. What is the formula? H2O. H2O means water contain two elements. One is hydrogen and the second one is oxygen. Hydrogen is present. Hydrogen and oxygen. Can we separate them? Can we separate hydrogen and oxygen from water? It's not possible by physical means. Can we break it? Can we break water to get hydrogen oxygen? It is not possible, right? So water, the substance contain particles which are attracted, right? We can't separate, one molecule of water with another molecule. They are also having some attraction forces between them. Can we cut the water into two different water stream into two particles? No, right? Because water, any matter you take, particles, they have attraction forces between them. Even if you see particles of matter, right? The particles have attraction. If I see this is one water molecule, this is another water molecule, this is another water molecule, these particles have attraction forces between them. What are these called? Attraction forces. These attraction forces are called intermolecular forces. They are called intermolecular forces. Okay, let me use this IMF. Okay, it's like intermolecular forces. Particles of matter have attraction forces between them. Because of these attraction forces, matter exists in different physical states. For example, metal. If you see metal, iron rod, okay, or gold bar, if you see, can we separate atoms? They are very strong. Can we break them easily? Not possible, because the attraction forces between metal atoms is very, very stronger. So we cannot break, we cannot separate. We need a large forces to break the intermolecular forces between metal atoms, metal particles. Like that, every matter you take, the particles have some attraction forces. They are generally called intermolecular forces, right? Particles have attraction forces between them, right? Some kind of matter have, all particles have attraction forces, but in some type of matter, the particles have weak attraction forces. Okay, some other matter, if you see, particles have very strong attraction forces, right? If you see metal, the attraction forces between metal particles is very strong, where in case of gases, let's see, for example, oxygen gas, hydrogen gas, in case of gases, the attraction forces are very weak, right? So generally, every matter, whether it is solid matter, liquid matter, or gaseous state, all matter, particles between them, right, particles of them generally have intermolecular forces between them. This is one property of particles of matter. Particles, this is related to particles. Particles have attraction forces between them. And next important one is particles have spaces between them. Particles have spaces between them. Spaces between them, right? Let's say if I take, this is one particle of matter, this is another particle of matter, this is another particle of matter. So we have some spaces. You see these spaces, right, between them. These spaces are generally called intermolecular spaces. Intermolecular spaces, or we also say interparticle spaces. Interparticle spaces. How do we write? IPS or IMS, right? IMS, intermolecular spaces, are interparticle spaces present between particles of matter, every matter, most of the matter, okay, particles have spaces between them. But same as the forces, spaces are also in some kind of matter, large spaces are present, in other kinds maybe small spaces or no spaces are present between particles of matter. These are the two important properties of particles of matter, right? Now, so the third property of particles of matter is particles of matter are in constant, or particles of matter are in constant motion. Constant motion. So what is constant motion? That means particles of matter constantly moving from one place to another place. Okay, this is not same for every matter, every particles of every matter. Okay, particles of few matter, okay, movement is restricted, whereas particles of most of the matter, particle movement is, we can see. For example, if you take gases, generally, if for example, if we light an incense stick, agarbatti, if you light it, what happens? It start emitting some smoke, and that smoke, generally if you light it in puja room, prayer room, right, what happens? That spreads to every part of the house. That fragrance, it comes to living room, it comes to study room, it comes to hall, everywhere the fragrance comes, like because of the smoke. Whatever incense stick particles, when lighted, they start constantly moving and spread throughout the available space. So from this we understand what particles of matter are in constant motion, or they always constantly move. Okay, so we have an activity to understand particles of matter are constantly moving. We have an activity. Let us see that activity now. Yeah, now we'll discuss an activity to understand that particles of matter are in constant motion, right, are constantly moving. So let us as I take but in scientifically, how do we understand, right, particles of matter are in a constant motion? So for that, let us take a test tube. Let us take a jar or a test tube. Let's say this is a measuring jar. Let's take a measuring jar, right, which is filled with a bromine liquid. Okay, what is it? It's a liquid bromine. It's a bromine. Bromine is an element that is generally in liquid state, but it produces vapors very fastly, right? So it produces vapors of the bromine, right? Vapors of the bromine. These are what we say, vapors. These vapors are actually brown color vapors. Now, if this glass jar, okay, on this glass jar, if we use another glass jar containing air, is inverted, this air is also completely turns into brown color, right? It is because you see, whatever the vapors produce, the brown color vapors produce, they completely moves and occupies all the available space and turns this colorless air also into brown color. From this we understand what particles of matter are in constantly moving. So to prove this, the constant motion, this phenomenon, so the particles of matter are in constantly motion is called a diffusion. So this is one of the properties of matter. We discuss about diffusion in detail in our next topics. Now, there was a scientist called Robert Brown. There was a scientist called Robert Brown who used to explained this motion of particles experimental, right? For this he took a watch glass, like a watch glass which contains some pollen grains, and watch these pollen grains under the microscope. when Robert Brown identified these pollen grains, observed the pollen grains under microscope, he found that these pollen grains are not moving, they are at rest. They are at rest, they are not moving. Okay, then what he did next, to this, the same watch glass which contain the pollen grains, like this on a watch glass, he added one drop of water. So he added a drop of water that generally spreads on the watch glass. Let's say these are pollen grains with one drop of water is added. Then when he observed these pollen grains under microscope, then in this case these pollen grains are continuously moving, like in zigzag motion. Like these particles you find, they move like this in zigzag motion. Okay, this is whatever you see. What is this? This is a zigzag motion, zigzag movement of pollen grains, right? Let us see what Robert Brown concluded from this activity is, when pollen grains alone pollen grains are taken on a watch glass and observed under microscope, what happened is these pollen grains are at rest. Are they moving? They are not moving, they are at rest. But when a drop of water is added, each pollen grains they are moving continuously in a zigzag motion. It is because when water drop is added, the particles of water are in constant motion, and when the water molecules are in constant motion, they hit the pollen grains, so that the pollen grains are also moving in a zigzag way. And this zigzag movement of pollen grains is called, he named this motion as Brownian motion of particles. So Brownian motion is not a spontaneous one. Brownian motion is an outcome of the phenomena diffusion, right? What is diffusion? Diffusion is a spontaneous movement of particles of matter, and it's called diffusion. When, like water particles are moving spontaneously. What is the meaning spontaneous? Spontaneous means themselves, without any external cause. If something happening itself, then it is called a spontaneous. So here, when water, if you see water drop, in that water drop, I told you earlier, nearly 10 to the power 21 water molecules are present. All those water molecules are in constant motion themselves without any external cause, and that spontaneous movement of particles of any matter is called diffusion. And when that water drop is added to watch glass containing pollen grains, that moving water molecules hit the pollen grains in their way, so that pollen grains are continuously being hit by various water molecules, and that pollen grains are moving in a zigzag fashion, and that zigzag movement of pollen grains is generally termed as Brownian motion. So we can say, what is it? Diffusion is cause, okay, but Brownian motion is a result, So without diffusion, Brownian motion is not possible. So diffusion, it's a spontaneous thing, whereas Brownian motion is because of diffusion, which is not a spontaneous, it is non-spontaneous one. So this is another property of particles of matter. What is it? Particles of matter are in constant motion. They are constantly moving. That we understand from these two activities. One is did by Robert Brown and named a phenomena, he identified a phenomena called Brownian motion. Whereas this another first activity, like using bromine vapors and air, right? This is used to identify the particles of matter are constantly moving. So with these activities, we understand, what do we conclude? We conclude particles of matter are are constantly moving. Constantly moving. Okay, but you can ask, sir, when particles of matter are constantly moving, why not chair changes its place itself? Right? It's a better, right? We understand. Whereas if you pour some water on the floor, what happened to the water? The water flows from one place, generally higher level to lower level. It flows itself. Why does it flow? It flow because the particles of water are always in constant motion. Because of that constant motion, water flow. Whereas that motion is very least or not possible in case of solid objects like chair. So that chair doesn't changes its place, its position with respect to time. Whereas water or else gases, different gases, perfume, like if you spray perfume at one place and that spread all the entire the room, right? It is because of particles of that perfume are in constantly motion and they occupy all the available space. Okay, I think you understand properties of particles of matter. Particles of matter are very tiny. It's right. Particles of matter very tiny. They have intermolecular forces between them. They have intermolecular spaces between them, and they are always constantly moving. They are motion. So these are the properties of particles of matter. This is one of the important questions which is oftenly asked in the board exams, right? What are the properties of particles of matter? Particles of matter are very tiny. Particles of matter have intermolecular forces. Particles of matter have intermolecular spaces, and particles of matter are always constantly moving, right? These are the properties of particles of matter. And now let us continue properties of matter, because properties of matter has mass, matter has space, like it occupies volume, and it is not a continuous one. It is made up of particles, and that particles are very tiny, having forces, spaces, and in motion. Now let's see the next property. These are what are this? These are what? Properties of particles. Properties of particles. You better take a screenshot or make a notes. These are properties of particles. Okay, then how about properties of matter? Properties of matter has mass, right? It occupies space, and it has tiny particles. It has what? Tiny particles. It is not a continuous one. These are the three properties. Now along with this property, let us continue this topic, right? Properties of matter, right? Not particles of matter.